Welcome everyone to another video where I show you how to detect simple outliers using R. For this exercise, we will be using the same protein dataset that you've already seen before. So in order to download the dataset, you can simply click on the protein dataset and download it. You will also need two packages installed in order to complete this week's exercises. The first is the cluster package, which you can simply type install packages cluster. And the second package is the DMWR package, which you're going to need a little later on in the exercise. So I've already downloaded the protein dataset. Again, you've already seen this before. So in order to read the dataset, I first have to set my working directory as follows. So students, you then have to put down your uni ID. And then I've downloaded the file into the download folder. So I set my working directory. Now, if you have obviously a different working directory, for example, you downloaded the file into your local machine, then you have to make sure that you know exactly the pathway or the path where the file has been downloaded to, or the file has been stored. Then I can simply type the name of the file that I want to name it. So in this case, protein df, and then I'm going to use the read CSV function to read the data set. Now, if I want to see what the data set actually looks like, so I'm just going to look at a portion of the data set. In this case, I'm just going to type head protein df, and you will see that it only shows 6 observations or data points from a 25 data points that you have in the data set. Now we want to do simple cluster. We want to do simple outlier detection using cluster analysis, or some of the concepts that we've talked about in terms of clustering. So if you remember, we could create clusters by simply setting the seeds. Now remember, setting seeds is essentially going to help us to generate the same results every single time. So I'm setting the seeds at 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to create my first cluster using the k-means approach, protein df, which is my data set. And I'm going to look at, and I'm going to create clusters based on red meat and fish consumptions. Going to use 5 centers or Ks essentially, and then I'm going to start from 10. Okay, so I might have made a small mistake, but that's okay. We can simply just copy and paste, and I just created my first cluster using 5Ks. Now, if I want to see what the clusters actually look like, again, we've already done this as part of cluster analysis. Now you will see that I have 5 clusters based on the red meat and the fish. Now, just by creating clusters, we are able to identify outliers. So in this case, by just looking at the clusters, we will see that, for example, number 4 or cluster 4 only appears once, right? So that should indicate, or that should tell us that that particular observation or that particular cluster, because it's on its own, then there's a good chance that cluster is an outlier. Okay. Now we could even do this. We could show the results based on the size to even tell us better about what I just described. Again, we're going to talk about this more during the lab, but essentially you will see that the first cluster has 5 observations, the second 7, the third 7, but the fourth cluster has only 1 and 1 observation. Now we want to know what observation is that. We kind of talked about this in the lab in relation to, for the clustering analysis, but as a reminder, let's just have a look at what this cluster belongs to. So I'm just going to copy and paste, and you will see that the cluster number 4 is Portugal, which is a good chance that Portugal is a good candidate for outliers. Now, the question is, okay, well, not every single time you're going to be able to identify the actual K or the actual centers that you require to identify the outliers. So for instance, if you had 4 clusters, which is the case for the next instance, if you have 4 clusters, how would you be able to identify outliers? By just looking at the clusters that you created. So let's just have a look. And if I check GroupMeet again, I will see that I have 4 clusters, and it's very difficult to identify which one is an outlier. We already know Portugal is an outlier, but by, for example, selecting 4 Ks or 4 clusters, there's no way for us to identify. So how do we go about it? We have to go through a process, which I'm not going to explain, I guess, in terms of the problem solving mindset that goes behind solving this problem. You can obviously have a look at the concept in relation to, okay, how do we identify clusters, or how do we identify outliers, which is based on the distance from the average of the clusters. We will talk about this in the lab in more detail, but I'm just going to give you a quick sort of a step-by-step, very informal sort of description as to what each step actually means and what each step actually does. Now, I also encourage you to sort of think about what is a better way to write this, or what is a better way to actually go about solving this particular problem. Because R obviously doesn't have a particular package, or it doesn't have a particular sort of function that we could simply call and get this sorted. So we have to do it manually. Now, again, I'm just going to give you a brief sort of step-by-step description as to what this means. And hopefully when you're going through the lab materials and when you're going through the lab questions, you should be able to understand it in a better way. So the first step, what we are doing is we're actually mapping the cluster mean we computed earlier for each cluster number to each observation we have in the data set. So by using fit, we are going to map the results. As you can see, red meat, fish. So it's sort of mapped to each cluster. And then what we are doing is we are going to find the difference, or a simple subtraction, between each point in the data set and its cluster mean. So the second, I should do this as well. How about copy the whole thing so you will also understand what we are doing. Okay, now, like I said, we have 25 observations. So we are finding the difference between each sort of average to the data point, or to the observation data point. So for instance, if I type protein DF, you will see that the first one, red meat, is 10.1. So 10.1 minus 7.9 gives us 2.1. So that's essentially what we are doing. In the third step, we compute the distance from the relevant cluster centroid. So this is the third step. And by distance, we refer to the Euclidean distance. Okay, we're doing it only for red meat. So we're finding the distance. And then we are going to tidy up the results by putting the country, the distances, and the cluster numbers we have together in a nice and sort of neat way. So how do we do that? You're going to okay, so like I said, country, the red meat, and also the cluster, we are all going to put everything together in a nice way. Then we are going to use a group by function, right, to put everything into their relevant group. So to do that, we are going to do this, right? Next, we are going to tidy up the results, Okay, again, we are going to tidy up the results. And to do that, we are going to use the function that we have already, and then we are going to merge the results. And by merging, I'm talking about merging the cluster average we computed earlier with the distance for each observation. And finally, in the final step, we are going to find the ratio of the distance to cluster center for each data point to the average distance to the cluster center, which we identified, which we sort of defined earlier. Okay, and that would be the results. Now, this is just a very, I guess, descriptive step-by-step sort of instructions as to how to go about identifying, the ratios and identifying the outliers. We're going to talk about this more during the lab. From now until obviously you've got your lab, again, I would invite you to sort of have a look at this and see whether you can sort of improve the way that we just created or we went about detecting the outlier. And here you can obviously clearly see Portugal. There's another sort of approach that we can take. I'm not going to go through this, and this is what I meant by you're going to require another package, DMWR. This is to identify the outlier through the local outlier factor, which is, again, fairly simple, fairly straightforward. So I'm just going to leave this for you to do yourself, and then we're going to talk about it more during the lab. So this is all from me today. Again, if you have any questions, if you have any concerns, please post them in the discussion forum or bring your questions to your next lab. Thank you again, and I will see you in the class.